नमस्ते। यो भिडियोमा चाहिँ I'll talk about the addition and the multiplication of 8-bit digit in a multiprocessor. Okay, so before we proceed to for programming, let me just clarify some very preliminary ideas. Consider this as a hard disk. यो एउटा hard disk हो. Every part of the hard disk is divided into a several minute part. For consider this is a very tiny part of this hard disk, and it is divided into the small room where data is stored. Maybe अब कम्प्युटरले स्टोर गर्ने डाटा भनेको बाइनरी फर्मेटमा हुन्छ. कन्सिडर दिस स्टोर डाटा ए, दिस स्टोर डाटा बी. Okay, so these are called bit. So this is 1 bit, this is 2 bit. The collection of those 8 bit is called 1 byte. Now let me consider the addition of the two 8 bit number. So before we proceed, let me write down the algorithm. Consider we have given two data, that is 05 and 03. So to add these two data, first I have to take this first data and then store it into the accumulator. Then I have to take this second data, then I have to store it on some other variable other than accumulator, because accumulator already contain the first data. Let us say this is B. Now I have to add those two value, and the result that I obtain, that is C. Then I have to store it in another location. Okay, so this is the algorithm, and then I have to execute the program, and then I have to check whether this location contains the sum of A plus B or not. So suppose if this is the address, a very tiny part of the hard disk where data is stored, let me specify this as the first address, which is given by 8000. So I'll write it down 8000, and then the mnemonic. What is the mnemonic for adding the data into the accumulator? The mnemonic is MBI and A. So what is the opcode? Because in the microprocessor you don't need to enter the mnemonic, you have to enter the opcode for the corresponding mnemonic. So MBI A. So this will be given to you during the practical, or you can download it from internet. That is not the problem. So if we check here, just search for the add A. Move A, MOV. So MBIA. So the mnemonic code is MBIA. What does this command do? This command takes the data from the user and it moves that data into the accumulator. Okay, so this is the function. So what is the code that we need to enter? That is MBIA. So we need to enter 3 and vertical E. So our data will be 3E, and after that we have to input our first data. Let me say that I am adding two numbers 05 and 01. So I have to add 05. Okay, and then in next step, now I need to store this data in another location. So for that, since accumulator is already occupied, and the accumulator is the part of the microprocessor where all the arithmetic addition and subtraction is done, so already accumulator is occupied, so I have to store the next data in some other location. So the mnemonic for that is MBIB. So if you search for the MBIB, okay, so here is the MBIB. which is code 0 and 6. So it is 0 and 6, and after that you need to enter the second data, which is 0 and 1, and after that now I need to add both of this number. So the mnemonic is add B. What does this code mnemonic do? It takes the value that is stored in B and it add that value with the number, the first data that is already in the accumulator, and give us the result. The code for this is add and the B. Okay, so the code will be 8 and 0, 8 and 0. Now the result that is obtained due to addition of both of this number, I need to save that result in some another location. So for that we have the code, the mnemonic is sta. What does this command do? It store the value to some specified address. So what is the code for this? sta, just search for sta. Okay, so this is what is 3 and 2, 3 and 2. Now I need to specify the address. Let me say 1 2 3 4. Okay, so the data will be saved in this location, and finally I need to execute the program, that is halt HLT, and the code for this is 76. You can check the reference here. See, 7 and 6. Finally now our program will be saved. Then I need to go and press execute to execute the program, and once executed the result will be saved in this location. Then I can check if this location contain the result or not. So, and our microprocessor is given in the lab is similar to this. Since I don't have microprocessor with me here right now, so I'm going to use the simulator, which is free to use. You can download it from the internet, and I have already prepared the same algorithm in Excel already. Okay, so it will be very easy for you to visualize and see what are the steps being taken. So before we start, we need to reset this microprocessor, and for resetting this microprocessor we need to press reset and we need to press exam memory. You can see same, that is this will be I think reset, and this will be exam memory. Similar layout and everything is similar. To display, to display, this will be for address, this will be for data. Now run the code. First define the memory address, which is 8000, and after every command that you press, you need to press next button. So next. Now already 3 has been given. If not, then you need to press manually, that is 3e. Next, what I'm adding the two number, that is 05 and 01. Okay, so 05 and 01. So command will be not 02, 05, and the second data is 01. Okay, so after pressing next, it is 02, which I have done previously with different digit. So I'll press 05. Okay, press next. Now it is already stored in our accumulator. Okay, so now the next code is to store the next value. We have the 06, which is this mnemonic code. Already it is given. If not, then you need to press manually 06 next and enter the second data, which is 01. Okay, so it is already 01. So next, now to add the both of this number, our code is 80. It is already given. If not, press 80. Next, now I need to save the result in some specified location. For that, the mnemonic is st and the code was 32. Then enter the new location, and next I'm storing this value into 8010 address. So you need to press first the last digit and then first two digit. So 10, next 80. Next, now finally I need to stop this program, which is the code for that is 76 already given, so I'll just press next. Now to run this program, first let me bring this microprocessor into the initial state, that is reset and exam memory. Then go and enter the first reference address from where this code has begun, that is 8000, 8000, and then press execute. Okay, so our program has been successfully run. Okay, you can also see the same result here. Now to check whether the result of addition of both of these number is stored in this variable or not, check this address. For this you can go reset exam memory to bring the microprocessor into the initial state, then press go and then press this address 8010 and then press next. Okay, so the 5 plus 1, that is 6, which is the given result. अब तपाईहरुको भाइभा चेक गर्ने आउने सरले के भन्नुहुन्छ, मलाई प्रोग्राम गरेर देखाऊ, म दुईटा नम्बर दिन्छु भन्नुहुन्छ है. he will give some two random number, so you need to do this. यति गरेपछि भाइभा सर पनि खुसी खुसीले हजुरलाई नम्बर हाल्दिनुहुन्छ. ओके, यो कुराहरु भयो. In the next video I'll talk about how to multiply the 2-digit number in microprocessor. I hope clear भयो. If in case केही confusion भएमा you can write in comment section. Thank you for watching. Thank you.